Everyone, welcome back to the channel. Today we are talking about data partitioning, the process of splitting a large dataset into smaller, more manageable pieces to improve efficiency, scalability, and performance. Whether you're working with database, big data framework, or machine learning, understanding how partitioning works can make a huge difference, and it could also save you in your systems and interviews. As always, we answer the what question. So, what is exactly partitioning? Data partitioning is a practice of dividing a dataset into smaller segments for easier handling. There are two main ways to do this. Vertical partition, as you can see here, this one is to split columns into separate tables or data stores. And there is horizontal partitioning, which to split the rows across multiple data stores, typically using a specific criteria like a range of IDs or hash functions. These these smaller partitions can then be stored or processed independently, which is especially handy when your data grows quite massive. Okay, um, let's try to answer the other question, which about why do we need partitioning? We need partitioning first for performance improvement, like by targeting only the relevant partitions, you can retrieve or process data faster and reduce overall load on the system. Number two, scalability. As dataset grows, partitioning makes it easier to distribute data across multiple servers or storage solutions, allowing horizontal scaling without a full overhaul. Number three, efficient resource utilization. Processing smaller chunks individually means systems can dedicate resources precisely, reducing overuse or memory or CPU. Number four, enhanced manageability. Like backups, restores, and maintenance become simpler with a smaller subset of data, enabling better data governance. Um, we can take some examples of partitioning. Number one, we can talk about databases like raw relational databases often partition tables either horizontally, which to partition by date, or vertically, which to separate rarely used columns. Number two, we have big data frameworks like Spark, for example. Spark data is split into blocks or partitions so that different clusters nodes can process them in parallel. Number three, it is used in machine learning, like data sets can be partitioned for distributed training or for splitting data into training, validation, and testing sets in more flexible ways. There are just a few examples, but essentially any system that deals with large or fast growing data sets can benefit from partitioning. Okay, there are some key considerations that we need to think about when we deal with partitioning. Number one, we need to partition the key or criteria, like the method you choose to split data, like range, hash, or specific columns, can heavily impact performance and load balancing. Number two, we need to think about data access patterns, like make sure to analyze how your system queries the data. Choose a partitioning strategy that minimize cross-partition queries. Number three, maintenance and rebalancing. Over time, partitions can get uneven. Plan for how you will monitor and rebalance them if needed. Number four, costs and storage. More partitions can mean more overhead in indexing or storage structures. So you will need a balanced approach. Picking the right partitioning method it isn't always straightforward. So taking time to plan can save big headaches later. So that's it for this video. It was a short video. We talk about partitioning, and let's make a wrap up. Um, that's it, the overview of partitioning, splitting large data sets into smaller segments to achieve better performance, scalability, and manageability. Whether you adopt vertical or horizontal partitioning or a mix, understanding these techniques can greatly improve your system capabilities. If you found this video helpful, please like, subscribe, and hit the notification bell so you never miss any video. Let me know in the comment section if you have used partition in your project and how it did work out. Thanks for watching this video, and see you in the next videos.